Alright, hello again, everyone. Um, Back again with another daily Leetcode. This is the October 4th challenge. It is currently 10 p.m. Eastern Time, so it just technically isn't the challenge anymore, but I did complete it. So I'm just going to walk through the solution. A couple disclaimers. My solution that I came up with really quickly is not ideal. It's not a ideal time complexity. I know I usually go for that, but for time's sake and just with the way things are right now, I don't really have much time to fully explain the optimal way to do this, which is usually with a greedy algorithm. So we're instead just going to do my implementation of it that I believe is big O of nlogn. Believe. We'll double check that. So let's take a look at the question. 2491. Divide players into teams of equal skill. You're given the positive integer array skill of even length n, right? Where skill of I denotes the skill of the ith player. So whatever the skill level is, in this case 5 is the highest, 1's the lowest, right? And we need to make teams of size 2 such that the total skill of each team is equal. Alright, so by this alone we can already assert that the array is going to have an even number of players, so we don't need to check for that, right? The chemistry of a team is equal to the product of the skills of the players on that team, right? That doesn't really matter in this case. It's essentially an end product that we're looking for, but essentially what we're looking to do is make pairs, right? So conceptually, if we have, let's say, an array of 1, actually let's just look at this, right? Let's look at the example. Example 1. We have an array with a player of skill 3, player of skill 2, player of skill 5, player of skill 1, player of skill 3, and player of skill 4. So naturally, to get a baseline for what we need to check for is to pair the best player with the worst player. So we'd be comparing 5 with 1. When we add those two together, it's 6. And that's essentially all we need to know to determine if we can divide them into equal skill. Right? Because you have the extremes on both sides. You have the worst and the best. When you combine those two together, you get a certain number. So essentially, you need to sort the array first, and you need to essentially check or essentially get a sum of the lowest skill player with the highest skill player, right? And then we need to check with each index to see. So, for example, the second best player is going to get paired with the second worst player. The third best player paired with the third best player. So we're basically going to keep comparing each player and basically collapse inwards on the array. So, for example, right, we have 1, 2, 3, 4, 5, 6, right? So we're going to basically collapse in, right? So we're going to go in this way, and we're going to go in this way, right? So we have 1 and 6. So 1 and 6 are together, and then we end up with 2, 3, 4, and 5. We're going to pair 2 and 5 together, right? We're going to pair 2 and 5 together, and then we're going to be down to 3 and 4, and then, of course, we're going to pair 3 and 4 together. And if each one of these pairs, if all these pairs add up to the original amount of the best player plus the worst player, then we're good to go. And then essentially the end is just asking you to divide the players and basically add the multiplied pairs to each other, which is quite simple to do. So let's jump right into the code. So this is actually conceptually a pretty easy problem to work out. Optimizing is a little bit difficult, but essentially what we're going to do first, so we're doing this in Java, we're going to just sort our array, right? That's the first thing we need to do in this case. So we're just going to sort the parameter integer array of skill. So we're just going to sort that, right? So we have a sort array. We're going to, one thing to note here, you can see that we have a long return type, so we do need to return a type long, so we're just going to get our total initialized that we're going to add to and return later. But let's take a look at the examples again real quick, right? the output here is 22. You can see the pairs are the best player and the worst player, the second best player and the second worst player, third best player, third worst player, right? Added together, they're 6, 6, and 6. So with this, we know that we're good to go. And then all we need to do from there is take our pairs, multiply each pair, and then add them up to a total of a chemistry count. I don't really know what the point of that is, but we'll do it anyway. Right here, for example, the two players form a team with a total skill of 7, right? In the case that you only have 2 members, you don't even need to worry about checking to see if the other pairs add up to the same amount, because you only have 1 pair. And then in this case, you can already see this is already ordered. So our worst player is 1, our best player is 3. 3 plus 1 is 4, right? But then we have a player with the same skill as the worst player and 2, and that adds up to 3. So we would actually have an uneven balance here where the chemistry of the best player and the worst player would be higher than these 2 players, and it would be unfair, right? So if that ever happens, if we ever end up with a case where we don't have any matching pairs, we're going to return -1. So let's take a little dive into a for loop here, right? So we're going to say for int I equals 0, of course. We're going to say I is less than the length of the skill array divided by 2. And I'll get more into that in just a second. Because essentially, we don't want to iterate through the entire array, because we're only going to make pairs as we go up. So for example, with that example array I had, right, we're 1, 2, 3, 4, 5, and 6. We're only going to check these first 3 numbers because they're making pairs, right? We don't need to check the pairs for these numbers because they've already been checked initially. So we only need to iterate through 1/2 of the array and check for the complementary members of the first half of the array with the second half of the array. So we never actually need to iterate through the whole thing, right? So that is quite helpful. So I believe, with that being said, if I didn't do the array sort in this case, then that would actually make this an O of n, I think the O of n divided by 2 time, I think. I'm trying to think. Should be over. Actually, never mind. No. Wait, if we... Yeah. Sorry, my mind's running astray. That would still be O of n. Right, that would still be O of n. Because if you reach a very high number, it becomes essentially irrelevant. So yeah, O of n. Disregard everything I just said. So now we're going to take a variable here. We're going to initialize it as our sum. This is the number we're going to check with. So this is essentially going to be the worst player at 0, which is our I value at 0, plus the best player, which is actually going to be the skill length minus 1, which is going to get us to the end of the array, minus I. So this is the number we're going to compare with the sum of the worst and best player. So for example, in the case of 3 and I'm just going to make it a comment, so I don't have to keep typing it. Right? So in this case, right, we have 1 and 2, 1 and 6. That's the first index and the last index. Right? Add those together. Then we're going to take our index at 1, which is 2, add it to the index at the length minus 1, which would be 6, minus whatever I is, which is 1, which would be 5. 2 and 5, right? Basically compressing the array inwards. And now we're going to compare that to the lowest index and the highest index sum. Right? And that's just going to get us our lowest and highest sum. So in the case that we end up with a pair that doesn't equal the sum of the lowest and highest, then we already know we don't have pairs, right? It's going to be an unfair spread of team chemistry. And then all we need to do now is, after we check that conditional, we're going to take our total, and then we're going to add the product of our index at I, multiply it by the complementary index it goes with. So it would be essentially the same thing we specified in sum. We're just going to get the product of those, because now we know these are a valid pair, so we're going to add the product of them to the chemistry total, which is shown here, right? Because we know 1 and 5 are valid, so we're going to, or say 2 and 4, so we know 1 and 5 is our baseline, right? That'd be 6. Then we're going to check 2 and 4. The sum of 2 and 4 is 6, so we already know we passed this conditional, so we don't need to return -1. And so we know these are valid, these work with the worst and best player sum, and we're going to add to the total, right? And you just slowly iterate through. So now you can see when we run our code, oops, once again I forgot another curly brace. Run the code again. Oh, jeez. Yeah, that would help. So we're gonna need to, I think, yeah, right here. Yeah, it would help if we returned the number. So we're gonna return our total. All right. Actually, for the sake of the context of the question, we're actually gonna call this chemistry, because that's what it's called in the problem. We're going to call it chemistry, right? And we're going to return the chemistry value, if I can spell it correctly. There we go. And you can see, when we run it, we pass all the tests, right? And when I compare it to my submission, right, it's not ideal, certainly. And if I analyze the complexity, yeah, it's big O of nlogn. So, the reason being, the nlogn algorithm is the sort algorithm that we use at the beginning. So obviously, there's a way to do this without sorting. You can do it with a greedy algorithm instead. But yeah, this is a very easy way to implement it. And our memory complexity, I don't care too much about that, but it's big O of 1, so it's not bad at all. You can see this is my solution. I just used the word total instead of chemistry, but you get the idea. So that is the Java-based solution to the Leetcode challenge on October 4th, 2024. Again, this was not a very ideal solution necessarily as far as time complexity is concerned, but it is a very easy to comprehend solution that you can then sort of transfer into the greedy algorithms and get a better time complexity. But definitely let me know in the comments if you'd like me to cover this problem with the greedy algorithm solution. I would have no problem doing it at a later date. I just wanted to get this video out now just so I can release the video on the day of the challenge. So that is the solution to the challenge, and thank you very much for watching.